Screen sharing. All right. Hello. My name is Olof Simander. I'm doing my master thesis here at LiU, together here with Andreas, who very kindly has agreed to collaborate on this project. Also, a big thanks to Patrick to invite me to present here today. So yes, we're going to talk a bit about automated sports analytics with large language models, and we're also going to cover some SQL, of which, of course, in this case is structured query language. Let's start with a little bit of introduction. So what are we trying to do here, really? 49ing has a chatbot currently as part of their product suite, which Andreas is going to demo very shortly. It has a lot of interesting features, but mainly it allows to interact with the data in a natural language. And as the first panel pointed out very early, the communication, especially to players, to coaches, could be very good as you can interact with it iteratively. But what we are trying to do really is to expand the scope of this functionality. Currently, it's a bit limited in the access to information, but if we could increase the scope, then we can make the analysis more comprehensive, and it would still be accessible through natural language. So that's exactly what my research aims to do, is to expand the retrieval capabilities to addressing SQLite or SQL, I should say, databases. And the specific issue here is what we're going to call text to SQL. But before we move on into the research itself, I'm going to leave it to Andreas for a demo.
Thank you, Olof. Perfect. Thank you. All right. So as Olof said, this is it's been launched, I think, in November, and basically what we want to do here is we have whatever breakdown of the game that we have in data. We want to be able to make it accessible in natural language, or then also what we have on the data side that we can map with video. We want to make accessible with natural language queries. So if we break down this game, then interestingly, we have some strengths and weaknesses on the two sides. So we have, by our analysis, USA in this game against Sweden, I think semifinal, with an edge of the rush and of the forecheck, and then Sweden with sustained ozone possession where they generated most. So suffice it to say that from our analysis, there were things that the one team did better, and then other things the other team did better. So if I go to this AI coach here, then I have some prompts here that I can just use here, and then an easy one is what were the best scoring chances. Then based on the data, finds me those video situations or those sequences here, and shows me those. If I go then maybe a little bit more into detail, and what we want to achieve here again is what we analyzed on the data side. We want to be able to translate into natural language. So I might ask maybe at the higher level, write me a 200-word game summary. So maybe the competition here, not as stiff or challenging yet, because basically we've got to beat a journalist that has seen the game, and no offense to journalism, but in 200 words, make it somewhat substantial, and write me a 200 game summary. And then again, hopefully something is not just fluff, but actually some important information. So we see here, okay, 6-2 win, that's easy. We have the XGs in there. And then a little bit of generic language, but a differentiation from, 5-on-5, what happened 5-on-5, what happened all situations. So maybe let's be a little bit more specific and say who was the better team. And then what made the difference. So we wanted to be somewhat precise. along the lines of before. So we said that US were better off the rush and off the forecheck, and then that's what we get here, right? So we get some generic that were more efficient with their high quality scoring chances. There's not maybe that much analysis value in that, but you know, when we say, okay, from the attack scenarios, particularly off the rush and off the forecheck, which they scored goals from, then I think that's already quite specific and it reflects the data. So again, as Olof is going to show us, there's a lot more potential to that, but essentially what we use here is the analysis that we did. We translate it into natural language and we make it more accessible. You don't need to be an expert at running all the filters, understanding all the metrics, but you can ask the system in natural language.
Great, thank you. Let's move back to the presentation. All right, so before we dig into all this, I thought very quickly we could look at what this text to SQL is and why it's needed. So a short recap on what's called RAG. It's might have heard of course. It's similar to this, but RAG simply often uses a vector database, and what it looks like, if from the perspective at least of the large language models, is that you ask a question, you actually get some additional information, and then it's able to answer the question. But this does not work quite in a similar way on a SQL database. So we need a few more steps to do this. So the way to interact and query SQL database is by writing a query in code. And you need to also execute that very query to then get the same information. So one of the biggest differences here is that we do require a few more steps. And this can actually be integrated into an agent, I should say. So let's actually get into the solution itself. So of course, we have researched a few different solutions. We wanted one that it's LLM driven. Luckily, all of the state-of-the-art models for text to SQL today usually use a variant of these foundation models that we might encounter on ChatGPT and so forth. And we wanted some rigorous science behind it, and we landed on a solution that is called a React agent, which some of you might have heard of. It's one of the better researched variants, but before we move on here, we might want to specify what an actually agent means in our use case. It's not really a consensus maybe on the exact definition, but for our purposes, it's an LLM that iterates and it uses tool to accomplish a task. So iterates, and especially the tool usage. So how does it work? You start with the question in the green bubble up to the right, and then it moves into a thought, which you can think of as regular output of an LLM. It then moves into an action, which is the use of one of these tools. And simply speaking, for our purposes, it's something like a programmatic function. It has a text input and it has a text output. And we also include the observations of the result of this tool or this function. And this loop can iterate until it has completed the task. And then you can stop either early or later for a final answer. All right, so I thought very quickly we could go over some of the tools. So what is required for an SQL agent? Well, you might be good to list the tools in the database. What does the database actually contain? And we're not going to delve too much into this in this presentation, but you can add additional context, for example, in a Postgres database using comments that can add very much that additional context, additional information, which makes using these tools much easier. It's a key to our design in this case. We also have a schema displayer, which allows to display the full schema of certain tables that you pick from this list. And you can use for one or multiple tables at a time. We then have the most complex tool, and that is the query analyzer. And this is a separate LLM instance. So you will have one LLM talking to another instance of an LLM. They're talking to each other. And it's formally speaking, a collaborative framework where they try to assist each other with different specializations to reach the end goal. We also have something I've chosen to call the query runner, and it's simply that it can execute these queries, so we can run the code on the database itself and get additional information this way. So let's move on. I've called this section the early results. Unfortunately, the thesis isn't actually completed, but we have some early results to show you today. And I thought the easiest way would be to actually just include some of the tables. So we'll try to make this a bit easier to read and understand. But if we look at the very first table, we have two different names of LLM models. We also have the SQL Agent Plus, one of these models, which means then we are actually using the agent itself. The very first row with only the name, it's what we might call a naive solution. It's very basic, but it's able to do the task. So what are we looking at? We're looking at these numbers between 0 and 100, and you can think of it as a percentage. Higher is better, and it's a number of the query it creates. Does it actually run on the database? Does it throw an error? And as you can see here, generally, the 91.78% of the time for the Qwen 2.5, it does generate a valid query. It's a lot higher, of almost 97% of the time, using the agent, for example. So it does appear to be better. We can get into a few examples later of how it does this, but at generating correct queries. The second table, very quickly, a bit more difficult, but we have two metrics here. So we have the EM and the EX. So those are the two major columns to look at. So let's start with the EX, and it's simply that the SQL query generated, when we run it on the database, does it actually return the correct result? We don't care how you got there, but does it return exactly the correct result? And these, very same way, 0 to 100, 100 is better. And so for the Qwen model, we can see that actually using the SQL agent rather than just the LLM does actually increase the score. However, currently using the Llama 3.1 model, it actually decreases the score, which is a bit unfortunate. But very quickly also, we should touch upon the EM metric, which is a bit different. That's an exact match. And using this benchmark to test just the text to SQL capability, data engineers have created a correct answer, and we can compare the queries, so the correct query with the generated query, and if they contain the same components. So in other words, does it write SQL like a software engineer, more or less? And in this case, using the SQL agent, it's a lot better at generating what might be considered correct queries to solve a task, and it actually thinks efficiently in that sense. But yeah, let's move on to some of the more interesting parts. So I thought I would end on a few examples. The first one starting from the benchmark, so a bit more detailed in how it actually works. So hopefully the takeaway from this is that you can see how it iterates to get to the correct answer. So it gets a question, what are the different template types, codes, and how many documents use each type. And you can see here it starts out planning on how to approach this task. This is a very simple question in the scope of things. And it also invokes the use of the query analyzer with a query appended to it. And you can see then it moves on to using it, and it accepts it and moves on to run the query. However, the query is not correct, so it uses an invalid column in this case. So what does it do? Well, it doesn't stop there. Instead, it goes back to the analyzer, corrects the query in the analyzer, proceeds to then move on to the query runner, and it actually generates the correct result, and it's sufficient, and it stops right there. I should maybe add that it doesn't know if the response is correct. It can't check against the, what should you call it, the correct answer. It has to find what it finds to be sufficient to answer the question in that sense. But yes, let's move on to some more interesting examples. So a few quick ones, if we have the time, on the 49ing replica, what should we call it? A replica of the 49ing database. So an industry example, really. So this is the most basic way to start, I think, with one of the most basic questions. So can it actually convert natural language to an SQL query on an enterprise analytics database? And yes, we do have a few instances when it does manage this. How many players are there? A very general question, but it knows to investigate the database. And it does so very simply by listing the tables. It also then displays the chooses to display 3 different tables and the full schema of them, develops a correct query directly, executes the query, and the model believes that it is a correct answer, so it does submit it as a final answer. And without displaying how many players are in the actual database, it does get the answer correct this time. So as a very low bar, but at least something to pass. But let's move on to something more interesting then. So what's the next step? Next step might be something like this. So how many goals did Sven, sorry, I can't pronounce the last name, score in overtime in season 23-24 in the National League in the regular season? So it moves similarly to previously. It identifies the task, it lists the tables, displays 4 of these tables, their full schema, but it develops an incorrect query and it does not count the goals correctly. So it's able to generate a query that works. It does return a result. However, the result is 0, which in this case is incorrect. So you can see here how things can go wrong along the way. And this is especially because how you store the data in a database. Many of the benchmarks contain very simple structures, but in enterprise scenarios, things are often a lot more complicated. And then I have one last example to go through, which is probably, or I should say, I hope to be an interesting scenario where maybe you can ask it these wider questions of who was the best goalkeeper? And keep in mind, it has no real context, so it has to infer a lot of things. You can see here it's ending up inferring that you're asking about the 23-24 season, which you haven't specified. And it's also found a way to measure this as well, which is, we can argue probably isn't the best way to do it, but it's a way to do it. So what does it do? It lists the tables, but it searches for the highest time on ice for these players in this season, which is an interesting approach. But what I hope you take away from this is that it's able to find an approach, it's able to put it into some context, and with a solution that's much better than this, maybe you can start asking these questions and actually automating the analysis itself. But in this case, it does end up back and forth, solving the task it has specified for itself and thus return an answer at least. But yes, so very quickly to summarize. So 49ing has developed a multimodal AI coach, and it's able to use many of the features in the full product suite even. A React agent can be used to interact with the SQL database, and retrieve additional information in the wider scope. The React agent clearly struggles with some of the complexity from a larger enterprise database. And what we haven't touched upon too much here today is that some of these complexities can be negated by using in-domain external information, a fancy name for saying we can tell it more about the specific database it uses. It only needs to be an expert on, say, one database or maybe a few. And lastly, hopefully it does show some promise in these results that it can actually be a very good solution for this in the future. Yes. thank you very much, and we open up for questions.
Now I have questions.
Great.
They've just got 1 million crowns. Should they hire you to build this model so it's a black box for their own team? Because the model that would be 49ing would be open to just about anyone to use in theory. You could build a black box for a team so that they could go in and put all their data in and then ask questions. Did we play a good game? What can we do better? How can we do this? And then learn from itself.
Yeah.
Or am I overthinking it?
I'm here together with 49ing, so of course you would choose 49ing as your. It would be a simpler approach, I think.
If I put it a different way, a lot of companies that I've talked to about just with AI, one of the biggest concerns is that if you do it on an open source, then you both share all your data, you give away your data, and other people can use it to their advantage. Where if you build your own box and you keep it in your own source, it's your own source, and as hockey teams or athletic teams want to fight for advantages, I wouldn't want to share it. But that's pretty much what you're doing here, isn't it?
No. Well, there are two things you can hide, I guess. You could hide the data itself. I mean, in the case of an analytics company, I feel like it's quite natural that some of the data is proprietary and a competitive advantage, and is fair. One other thing you could, of course, hide is that your solution of how you work on this data. What is your AI agent, or do you use another solution, which naturally also could be proprietary and a competitive advantage. Not unlike the agent race that's currently ongoing, that you don't actually know exactly how all the services are created.
Maybe just to add to the point, I think there's a lot of competitiveness, but there's also a lot of common ground on what we need, and then cost is always a factor. So if there are solutions that can cater to common requirements, then that's something that can easily be done with this. And yeah, you can for sure kind of hire then your own guy that can take it to another level and make more of that. You can ingest your own data if you want to dig into this. But again, we're talking about the pro hockey, sure, but we're also talking about youth hockey,
sure.
And we're talking about how can we better develop our players, and for that, how can we access relevant information in a faster way. So I think the proprietary bit is maybe the biggest in the NHL, and then anywhere else you go, I think there's always talks with how can we be better together. And then sure, there's some proprietary components where teams want to have an edge over the competition.
Can you use videos to put in the information, or does everything have to be text?
For my project, the master thesis project, it has to be text, unfortunately. But as we have seen, well, your solution, depending on your definition, I would say it's multimodal. It's able to display videos and find these.
Interesting.
Sure. So 100%. I mean, video is huge. We spoke about before with the guys on the teams that we want to be able to find results in the data, but then the communication to the players normally is with the video. So that's what we spoke about, or what Olof talked about. Those are ways how to increase the potential of this whole pipeline. And then whether it's text or video shouldn't matter. So you should be able to find whatever video you're looking for.
Tim?
Very nice work. It's very interesting. I get why you're doing this. I was just curious if you had thought about comparing, just say with an LLM, just to try some of the same queries to see if it came up with better answers or different answers than what you were getting from the SQL backend.
Do you mean using something like ChatGPT then to...
Yeah, just ask it, like, which was the best SHL goaltender in 2024, 25?
So you mean that it's baked into the memory already in that sense?
Yeah, just curious.
I have not tested that part, but as I can very clearly see, well, let's move back actually to these parts. Well, the output of the actual model is very detailed. Sorry, like in this green text, and there can be a lot of output for a single question. So I can see that it fetches the information from the database. But to your point, yes, it might be, even though it uses the correct steps, it uses the database to find the information. Potentially, it knows when it's arrived at the final answer because it knows the correct answer. And that is a confounding factor.
And then I was also curious if the person speaks SQL and they talk to it in an SQL-like way, I'm guessing that it works much better.
Oh, yes. So it's a lot easier if you format the question almost like a query.
Yeah, yeah.
And it's some of these, we are using a benchmark to test the text to SQL compatibility. Some of those questions are even the code itself, the SQL code is the question.
Yeah, yeah.
And you can see how it handles it.
Nice.
Yeah.
Thank you.
Thank you. Very interesting. Just curious, do you think how can you make sure that the text that is generated is not mixing up with data from internet? It's not biased. I mean, for example, maybe in the internet there are some random data that say this team is the best or this goalkeeper is the best.
So
and then contradicts with your data.
So you mean that it has something like how do you call it? So it has already decided on which the best player is.
Yeah, there are a lot of articles on the internet. You already have seen that, and a lot of blog posts that they are explaining about that without any like back data analysis or something.
Yeah, it's a good point. Yeah. Take, for example, this case when we asked about the best goalie. So it's very easy when you develop this agent because it's very easy to spot how it's thinking, all the traces, how it navigates to the answer. And it does specify very early that, okay, I need to find the best goalkeeper. What does best mean? And it just defines and says, well, time on ice, maximum, that's the best.
Sorry, this agent is trained before you are giving it a new data, right?
It's
a pre-trained model.
It's well, to be very correct, it's an instruct model. So almost like these llama models, for example, are open source, the Quen models as well. And we are not doing any fine tuning. We're not doing any additional training. And this is also sort of hidden almost in the actual title of the paper. So SQL RAG, or Structured Query Language Retrieval Augmented Generation. So we're trying to actually give it the information, but in terms of prompts, in text, in the conversation itself, we're not training it on the actual data. So it's two different approaches to get there.
Okay.
Hopefully it's answered your question. All right. Thank you very much.
Thank you.